Good morning. I'm going to talk about the state of sentiment. Of course, I only have 20 minutes and I don't really have time to talk about everything. So I'm going to talk about something a little bit. And of course, I don't really know that much about industry, but I'll talk a little bit about research, of course. So everybody knows sentiments essentially try to do analysis of opinions, emotions, appraisals. There are lots of this kind of terms, and they are somewhat related. They're also slightly different. Okay, and it's a very active research area in natural language processing, and also being done in data mining and on the web and on the social media. There's some conference about social media and blogs. And it's a very challenging research problem. That's why it's very popular. And the problem is it's actually a semantic problem. So it's not that we're trying to analyze the syntax or something like that, but we're trying to understand particular aspects of the natural language, basically emotional or sentiments aspect or opinion aspect. It's challenging. It's also because it's a natural language problem, because there's nothing in the natural language which is easy, and especially we're trying to do some sort of understanding of it, and everybody knows there's lots of application going on, right? And also recently, or not just recently, there's lots of things going on in social science and management science. I give some talks in social science, also management science schools. They are very interested because if you think about anything related to politics, businesses, and even financial markets, or the health, they're all related to the human beings, right? Anything related to human beings, there's always sentiments, emotional opinions, right? Because we are that kind of thing, right? We like to express our opinion stuff. So let's give a quick, probably I'll look at this side, probably give a quick introduction. What do we mean by sentiment analysis? Of course, I'm just trying to define the core problem, not just peripheral. You can sort of extend from here to all kind of directions, all right? So let's just look at something very, very simple. I bought iPhone yesterday. It's such a nice phone. The touchscreen is really cool. The voice quality is great too. It's much better than my old BlackBerry. So what we are essentially trying to do in terms of research, in terms of trying to extract from this part of the thing, we essentially try to get something like this, right? What is the sentiment here, and what is the target? Okay. Of course, in this case, the person is essentially focusing on the iPhone, all right? But we can also go to the touch screen, and also goes to voice quality, all right? But this part, I'm not going to talk about this today, because I'm going to mention this a little bit in the tutorial, because this is talk about the comparisons. Okay, it's not just direct opinion. So essentially, we can define, if everybody probably here knows the database, we can define this as a schema, right? Essentially, what's the target, what is the sentiment, and also who has the opinion. In this case, maybe not very important, because just anybody on the street give us something on the Twitter or on the review sites. But if it's Obama, it becomes important. Okay, and the time is important because as time goes by, things changes, right? But this is not so easy to use in practice, and especially when you talk about products and services. Probably this definition is a little bit better, because you have the entities. Here you will say the iPhone. I'm talking about iPhone's screen, touch screen, not somebody else's touch screen. So you can split this part. I will just give you a better sort of understanding, and also a better analysis capability. Later on, if you do analysis, you can look at the entities. You can also look at the aspect itself. Okay, and you can do. I'm sure you know database. You can do all kind of stuff with this kind of structured definition, right? If you give me a bunch of text, I will produce this table for you, okay, a relational table for you, right? So essentially, that's the goal for the core sentiment analysis problem. Okay. Of course, you can go beyond that if you think the touch screen is cool, but the voice is quite. But you can also show a voice is clear, right? Voice is loud, so you can go beyond that kind of analysis. All right. But here we're just talking about what is the essential part. For example, here we say iPhone touch screen is positive. This is the person. This is the date. All right. You can see we have lots of documents. We can produce spreadsheets or relational table, right? Then you can do all kind of analysis using data analytics and sort of database tools. Let me go a little bit fast. So another aspect of the opinions and the sentiments, we have to summarize it, okay? Because everybody has one, right? It's not like facts, and you can say one fact. I mean, you can say 10,000 times the same fact. It's still the same facts. But here, opinion, everybody has one, and you have to have lots of people's opinion. You cannot just trust a person's opinion, right? And then we obviously have to have a summary, okay? Because this is different from the traditional text summary, right? If you think about text summary, you have a long document, you make it short. You have many documents, you make one document. But here we can define it precisely. What do you mean by opinion summary? It's not like traditional text. You can't really define it. Just say, I mean, get the gist of it, right? To get the main point. But what do you mean by main point? But here we can summarize very nicely and define the summarization and do it correctly, right? So here is very simple kind of summary. You say, touch screen. There's so many people like it, and so many people don't like it, right? You can also talk about voice quality. Obviously, we can go beyond that. See this, for example, scratch, right? The screen. Somebody just like to touch, somebody like to sort of think about scratching, get easily scratched. And then you can also do things like that, right? Because becomes visual, you can visualize it. Okay, you can get all kind of interesting visualization to do this kind of analysis. Okay, but this is just a very basic. And then you can talk about, how do we visualize it by comparing different kind of products, right? Not just one. So it becomes fairly clear from here. You know which one is better, right? So the blue one seems to be better in terms of a few things, but this is sort of similar. I did not see there's something here. So this is a very rich problem. So anytime people ask me what is the accuracy of sentiment analysis, it's a very difficult question to answer, because what are you talking about? Are you talking about just sentiments? I just try to get there's a positive, negative, or also you want to get the target of the sentiment, right? Because if you just think about, and also if you want to put them together, you want to get both of them correct, which becomes even more difficult, right? And of course, also, when you talk about sentiments, it also depends on what kind of text you're talking about. Because some type of text are simpler and some are easier. So I'm not saying easy or simple. I'm just saying easier or simpler, because there's nothing simple. Okay, there's nothing really, really simple here. So if you think about just these 5 aspects, of course, we are essentially I think 95 or even 99% of research is focusing on this part. Because on the social media, because most people working on the social media, this part is known, right? They are essentially, when you script things from the website, you'll get this information. But this essentially is a focus on how do you get it correctly, right? And obviously, then, since this is a natural language processing problem, you'll get all the natural language stuff in, right? And for example, how do you know voice is the same as the sound quality, right? And then and also, of course, lexical semantics is basically the meaning of the words, right? When you come to a particular context, what's the meaning of this word, right? And then call reference resolution, all kind of stuffs coming in. That's make this a very rich problem, and also a very challenging problem. Okay, very challenging problem. That's why it's not easy to get very accurate. And sometimes when you see people publish something 80-90%, which is because just focusing on one thing, one data set, which is possible. But if you want to do cross the domain, cross different kind of products, which is not easy. Okay, it's not easy. But we're getting there. Okay, I think we're getting there. I'm going to talk about that a little bit. So here is the state of the sentiment. And of course, I'm talking about the research. What is the cutting edge? What is the latest research? Obviously, all the problem we're trying to solve, but I'm just trying to say these few things. I'm sure you heard lots of things about deep learning. I'm not going to talk about deep learning, unfortunately, today. I'm going to talk a little bit in the tutorial. And it's still very hard to say whether the deep learning is helping. So we're still doing research. Lots of people doing research on this. And the people did some comparison, and it's hard to know, okay, at this moment. So I'm going to focus a little bit more on this thing called lifelong learning. You probably have not heard about this, and which is essentially a kind of machine learning. And I will try to say this is more advanced machine learning or just sort of a more systems approach to machine learning. And I'm going to talk about two things, which is live learning about sentiment classification. How do we know something is positive and negative? And also, I'm going to talk about how do you do extraction using lifelong machine learning. All right. So this is essentially the two things we are when all the sort of sentiment analysis people have been focusing on. Apart, of course, there are lots of other applications as well. And as of course, there's also the big data. Okay, big data thing. And both this deep learning and this thing need big data. Okay, without big data, you will not be able to do this effectively. All right. So, so the traditional machine learning, let me give you a short introduction. So the traditional machine learning essentially says, give me a data, I'm going to run my algorithm, I get a result, right? So I call that sort of learning in isolation. Okay, learning in isolation, without considering any related information or the past learned knowledge. Okay, past learned knowledge. All right. So you probably heard about lots of this type of algorithm, deep learning and SVM, naive Bayes, or the conditional random field or topic models. They have been very successful. Okay, in all kind of areas, and including sentiment analysis, and lots of research and lots of applications are using this technology. However, this thing has weaknesses. Okay, its weaknesses. The key thing is there's no memory. There's no memory. It basically says, I'm just doing this thing and that's it. And of course, it cannot. The knowledge you learned in the past, because of machine learning, right? You learn knowledge. So the knowledge you learn is not cumulative, which means you learn something, you forget about it, right? And you can't leverage the past information we have learned to help us to make it better, right, next time. And which is basically one of the symptoms is traditionally you need a large amount of training data, okay, large amount of training to do reasonably well. But human beings never do that way, right? We never sort of, I learn something and look at this data and I get this thing and I forget about nothing before. Next time I just look at another data, right? So we always use prior knowledge, okay, to help us to do better, right? And so this is what is called lifelong machine learning. You remember, okay, you remember, right? So essentially it says a learner performs learning on a sequence of tasks, already done 1 to n-1. You have done lots of stuff, all right? And then we're facing the nth task. This is a new task, all right? And we're going to use the knowledge gained in the past task to help us to do better this time. Okay, we're doing a new task. So why this is, we say this lifelong learning is so suitable for sentiment analysis. Because if you think about this, when you want to do this kind of lifelong learning, obviously the knowledge you learned in the past must be relevant, right, to the current task. If it's a completely different, that's no point. Okay, that's no point. But sentiment is actually a field which is so suitable to this, because if you think about sentiment itself, right, you cross the domains, those sentiment terms, expressions that basically can carry over, right? A lot of things you can carry over, all right? And also, the different product features, aspects. If you study for cell phone, a lot of them are the same as the camera, right? So you can see a lot of sharing of sentiments, expressions, and also the aspect of product features things. So then, obviously, that's a very nice feature, nice characteristic to do this kind of machine learning. Okay, so we can say, let's just talk about this one, sentiment analysis for using lifelong learning. So essentially, we say we're going to classify the document or classify the sentence. Of course, we can also classify individual aspects, right? And sentiment on that. So traditionally, we need a lot of training data. Okay, lots of training data to be able to build a model which is going to do reasonably well. And can we not label so many data? Can we just tell system a little bit, not much, okay? And can we do much better? Okay, can we do much better than even you have training data? Okay, so, but the problem is it's quite well known when you build a training data, for example, of a cell phone, you build a model, use that data, you apply it on a toy, it's not going to work, right? It's definitely not going to work. Okay. However, we normally say we can do transfer learning. Essentially say we can use this data. We have lots of data for this. And although have no data for this domain, for example, this is the cell phone, this is the earphone. I mean, we don't really have any data, but we can do something called transfer learning. Essentially, I'm going to use some data here to help me to do well in the next domain, which I don't really have any training data. Oh, I have a little bit. Okay, so this is the traditional, what is called a transfer learning. Okay, you transfer some information from one domain to the next domain. Okay, but I think this is not the best solution, and because as we said, we can do with a lot of stuff, right? So imagine we have worked on a large number of domains in the past. I'm sure a lot of companies have been doing that, and of course a lot of research institutes have been doing that too. And of course there's also a lot of data. You can do that without much trouble, right? You can scrape all the Amazon's data and then do everything, right? Do everything. And do we need the data at all? New data at all, right? I've done a lot of things. When I come up with a new thing, I probably don't need any data, right? And no, you don't need sometimes, not always. Okay, sometimes you can do wonders. Very good, very good. Okay, so some of them, let's just give you one example, but many of them can improve a huge amount. Okay, quite a big amount. But sometimes, yes, you do need you do need some data from this particular domain. All right, but in this case, say this is just an example. We have really worked on a lot of stuff, lots of things. Now I'm going to come to the toy. Now I have a review of a toy. Oh, it's not good. The result is bad. Okay, why? Because of this guy. Why this guy? Because when you say something is a toy, it's normally not good, right? Correct? When you build machine learning models, the machine learning just pick up these words, right? Do some, depending on the different kind of algorithm, it's basically a kind of linear combination of this stuff, right? Either you take log of linear combination or just direct linear combination of this thing. And then this toy, when you go to most of the domain, this is not a good word. But when you come to the toy, in the toy domain, no meaning. Okay, so you need to solve this problem. Okay, you need to solve this problem. Which basically means when you come to individual domain, you do have something which is specific to this particular thing. All right? So I'm not going to explain this mathematically, but just say we're going to deal with domain-dependent sentiment words. Okay, you can do it. Okay, it's possible to do that. And also you have to worry about domain level, because if you want to get knowledge from the past, you have to make sure that knowledge is correct, right? So if that knowledge only appears once, you probably can't trust it. If it appears many times, you might be able to trust it. Okay, I'm not going to explain this. This is just some penalty stuff when you get into the machine learning. So you can see the result going quite a bit of better. So this one, I'm just about sentiment analysis, the second aspect, second part, which is the aspect extraction. Essentially, we'll try to extract the product features, right? And then we have product features, which essentially is something like this, right? The battery life is long, but the picture are poor. So what we're trying to do, we are trying to extract this sentiment is about battery life and about picture, right? These are the target. Sometimes we call it aspect. Some people also call it topics or call it features, product features. And the research community call it aspect because the feature is not so good because it's sort of a conflict with machine learning's features. So again, the same kind of situation. A lot of stuff you can carry over, right? You can't just carry over from one domain, but you can carry over if you have lots of stuff, right? Which basically means you need big data. Okay, big data. So if you think about this, every product have a price, right? So there's similarity over there. And lots of those things has a battery, and many have screen as well. Yeah, so all this information are similar. And then you can use this information to help you to do better. It's rather silly not to use. Just say, I've got new data, I'm going to label this, I'm going to do that. Okay. And so in terms of how do we do that? So this is the modeling, this is the sort of probabilistic modeling thing. And I'll just try to explain what's going on with this diagram. So you have the data. This is the new data. And you can see this is the past aspect base, the stuff we have discovered in the past. I've done lots of stuff in the past. And I'm going to do some model here. I'm getting something from the current data. What do I have roughly, right? What do I have roughly? And then based on what I have, I'm going to do a match from this space. So for example, I got something sort of related to the battery, probably. I mean, some of them are not correct, some of them are correct. But I can sort of doing some sort of information theory-based match, distributional match. I can figure out, oh, in the past I've written down lots of stuff similar to this. Okay? And then I can do some knowledge mining to say what I have done in the past, many of them are pretty good. Okay, so I'm doing some data mining on that. And then if I got some knowledge, I'm going to redo the modeling. So here, that's what you call knowledge-based talking model. It's not just traditional unsupervised talking model. Okay. Of course, in this case, what's the difference here is also we are mining the knowledge automatically. We're not getting the knowledge from the human being. Okay, you can also say, how about get somebody to tell me what's the stuff over there? You don't need. Okay, you don't need. Okay, this completely can be done automatically. So after the data mining, after another run, of course, you can do many runs, and you get an output, you put it back, right? This is where we retain the knowledge we have got in the past to help us to do things in the future. All right. So you can do lots of better stuff. Right? So in this case, this is the blue one. I'll try to compare with other approaches. All right. So I'm just trying to summarize 20 minutes, and we'll just sort of right time. It's a quite well-defined semantic analysis problem. And there's two key aspects, sentiments and the sentiment targets, right? We are essentially, much of the research is focusing on this. And I was trying to say we're going to use lifelong learning, which is going to try to push us to the next level, and which is based on the key observation, because the sentiment analysis field is just really nice. You can see every domain that have something sharing, okay, which makes it really, really interesting. So lifelong learning is quite promising, and then see whether we can make this go to the next level. Of course, if you want to talk about other stuff, I'll be happy to talk about it. For example, deep learning or whatever you want to have an opinion, I can talk about it. Okay, that's it. Thank you.